IP, MPLS, and IP routing. Starting where we left off in the previous video, we now configure the router identity so that MPLS forwarding can carry the pseudowires. We also introduce IP routing to connect the Layer 3 components together, defining MPLS identity and MPLS IP on interfaces. First, we need to define an IP address as the MPLS router ID of each node. We do this by referring to the loopback 0 interface whose IP address we've previously defined. Next, we select the Layer 3 interface for each node and turn on IP MPLS for that interface, the VLAN 100 interface for node red, and the BDI 100 interface for the node blue. Enable IP routing. Now we need to enable IP routing to make sure that all the Layer 3 networks can find each other. In this case, we use the OSPF routing protocol by defining a routing instance, in this case with a process ID of 1. Now, for each node, we define the router ID, which is again the same IP address as the loopback 0 interface. Next, we include each of the networks that are to be distributed through the OSPF routing protocol. First, we include the addresses of any loopback interfaces, starting with the IP address of the loopback 0 interface for each node. Then, we declare the network address of an additional loopback interface that we'll define in the next video, which will be used for packet-based clocking and synchronization. The last step is to include the network subnets that are needed to communicate between the nodes. The 10.10.0.0 subnet is the IP subnet from the Layer 3 configuration outlined in the previous video, which is shared between VLAN 100 and BDI 100. So now the MPLS and IP routing configuration is complete. The final step is to check that the routing is running correctly, the MPLS is properly configured, and the machines can communicate with each other through the loopback 0 addresses, confirming routing and MPLS connectivity. We can check with this command that OSPF process number 1 is running and the loopback 0 interface is included as one of the configured interfaces with the correct IP address. Also, the L3 interfaces, VLAN 100 and BDI 100, should also be shown as interfaces running OSPF. Now would be a good time to check that the IP addresses and the subnet masks are correct for the displayed interfaces. Then we can see which routers are reachable. In this example, we're only configuring 2 routers back to back, so we should only see one neighbor, and it should show its loopback 0 address as its router ID. Similarly, in the output of the database command, the correct IP addresses need to be visible belonging to the correct routers. Now that the OSPF is running and we've checked that the IP addresses are correct, we confirm connectivity by pinging both the IP addresses of the remote machine. Both the 192.168 address from the remote loopback and the remote L3 address should answer. Finally, we confirm that the MPLS is running correctly. Here, we're simply looking to see that the MPLS is running on the loopback 0 interface and that we can ping the other MPLS router. Now we have back-to-back connectivity between the nodes at Layer 2, Layer 3, and MPLS. The next video will take us through the steps of configuring the clocking and synchronization.